In the solar system, there are 1.3 million asteroids, with approximately 700 of them orbiting relatively close to Earth. According to scientific estimates, each of these asteroids is worth roughly $100 trillion. Given the technical capabilities we have today and the potential economic benefits, it can be confidently stated that 122 out of these 700 asteroids are suitable for resource extraction. The world's most expensive metals, gold, platinum, rhodium, iridium, palladium, osmium, and nickel, constitute only a small fraction of the treasures found on the planets of our solar system and on asteroids. Asteroids were formed from the same material as our planet. They share an identical set of chemical elements. However, Earth underwent a process known as gravitational differentiation, during which the bulk of heavy metals, such as nickel, platinum, cobalt, iron, tungsten, gold, and manganese, settled into its core, while the upper layers of the crust were composed primarily of stratified rock layers that contain remnants of ancient flora and fauna. Due to technical limitations, extracting metals from deep within the Earth is virtually impossible, whereas on asteroids the elements are distributed relatively uniformly. These space rocks hurling through the pitch-black void harbor enormous reserves of valuable resources. The value of such little stones can reach quadrillions of dollars. One example is the main belt asteroid Psyche, to which NASA sent a probe in early October 2023. Scientists believe that the asteroid consists of iron, nickel, and gold, and if it were carefully lowered to Earth's surface, the nickel alone would be worth 10,000 quadrillions of dollars. In its upcoming mission, NASA does not plan to extract resources from Psyche, but simply intends to study it. The race among nations to exploit space resources has been ongoing for a long time. The goal of this race is not only to learn how to mine precious resources in space in the future and transport them to Earth, but also to process them on site, for example, to use as fuel or to construct settlements for future colonists. In 2019, Bao Weimin, director of the Science and Technology Commission of the China Aerospace Science and Technology Corporation, declared that China plans to establish a special economic zone between Earth and the Moon in space, which is expected to generate an annual income of $10 trillion by 2050. Some Chinese startups, including Origin Space, are developing technologies for asteroid mining. One of Origin Space's key projects is the NEO-1 satellite, launched on April 27, 2021, aboard the Changzheng 6 launch vehicle. This spacecraft serves as an experimental platform designed to test a range of technologies necessary for future space resource extraction, as well as to refine the technique of capturing objects with a space net, a crucial first step toward mining materials from asteroids. In the modern race to harness space resources, the primary players are the United States and China. Both countries are striving to develop robotic systems and reusable spacecraft capable of operating in microgravity to extract resources. American company Astroforge aims to become the first commercial enterprise to successfully mine valuable metals from asteroids and is actively working on developing the necessary technologies and conducting test missions. The company specializes in extracting platinum group metals from asteroids. Astroforge's Odin spacecraft is scheduled to launch in 2025 as a secondary payload on SpaceX's Falcon 9 rocket, alongside a lunar lander from Intuitive Machines. After separation, Odin will travel to the near-Earth asteroid 2022 OB5, reaching it approximately 300 days after launch. The mission's objective is to capture images and data of the asteroid to prepare for subsequent resource extraction missions. The race continues, but how will it end? In 1967, the Outer Space Treaty was signed, prohibiting the national appropriation of celestial bodies. However, in 2015, the United States enacted a law permitting private companies to mine asteroids by granting them ownership rights over the extracted resources. This creates a legal conflict between the international treaty and national legislation. Although asteroid mining is still in its exploratory phase, even a single incident could spark conflicts between nations. Extracting rare metals from asteroids might oversaturate the market, devaluing these resources and adversely affecting the economies of exporting countries. Moreover, extensive mining activities could increase the amount of space debris, heightening the risk of collisions with operational satellites and space stations. The absence of clear international agreements in this domain may also lead to military-political tensions, as countries could perceive such activities as threats to their national interests.